So far, we have trigonometric functions defined using the unit circle. Now we're going to look at a different context in which trigonometric functions could be applied, and that is going to be in right triangles eventually, but let's see how to get there. All right, so we are going to focus our studies on acute angles, okay? And acute, remember, those are angles that are less than 90 degrees. Um, and so when we work with acute angles in the context of the Cartesian coordinate system, that is going to restrict us to quadrant 1. Okay, and in this case, if we focus our definitions of trigonometric functions, remember that if we take kind of an angle approach, or we can take angle and arc length. We saw previously that if we went an arc length along the unit circle to, we're going to call this t, to a point, and this is going to be p of x, y, right? We could imagine that we treated this p of x, y as a point on the terminal side of some angle, some central angle theta, um, that is in standard position, okay? And in this case, we could say that sine had the value of y over 1, or was the ratio of the y coordinate to 1, which was the radius, right? We're on the unit circle. And then cosecant was its reciprocal. Cosine was x over 1, and secant was its reciprocal. Tangent was y over x, and cotangent is the reciprocal of tangent, okay? Now, we're going to take this idea and change it just a little bit, okay? We're going to drop an altitude, and an altitude, if you don't remember that, that's a perpendicular line. So we're going to drop an altitude from point P to the initial side, and so it would be a line that's perpendicular to the initial side, the x-axis, that goes through P. And so we get a little triangle, which I'll kind of blow up over here. Okay, so we'd have the origin, we'd have the diagonal line that is radius 1 because, or that is length 1 because of the hypotenuse. Here would be P of x, y. And then we have this straight vertical line, and here's our x-axis. And this, to indicate that it is perpendicular, that would be our 90-degree angle, okay? Now, if we think about this a little bit, how much are the other two sides? We can see that this forms a right triangle. How much are the other two sides? Well, the horizontal side, right? If we went to this point P of xy, that means we went over x units, right? We went x units this way. And then maybe at this point, we could treat this as point Q, which would have coordinates x comma 0. And then from there, we went up y units to get to P of xy, right? That's how the Cartesian coordinate system works. So in all, we have the length of our sides. And actually, our trigonometric functions still hold, and we still have the angle theta there as our base angle, that central angle, okay? And so with this, our definitions of the trigonometric functions still hold. It's just sometimes we introduce some additional language or some other vocabulary. So if we think about the angle in the diagram that I have here, I have it as x. Up above, I use theta. Same thing. It just means an angle. But with respect to the angle x in this diagram, right, we can label the other sides that in a corresponding way to this angle. So the side that is directly across from this angle x, we're going to call that the opposite side. It's directly opposite the angle. Okay, the longest side of the right triangle, we always call that the hypotenuse. Okay, hypotenuse is the longest side. Maybe one might want to make note of that bit of language. And then the other side, the side that is right next to the angle, we're going to call that the adjacent side. Adjacent means right next to. Okay, and so in short, we abbreviate these with sides H, O, and A. Okay, and so that's where you may have heard the acronym SOHCAHTOA previously. But when we talk about sine, the reason this acronym evolved to be SOHCAHTOA is that sine is opposite side over hypotenuse. Okay, so if you need to write out a little bit more, you sure can. Cosecant would be its reciprocal. So this is hypotenuse over opposite. Cosine is where the ka comes into play. So cosine is the ka part. Okay, adjacent over hypotenuse. And secant would be its reciprocal, hypotenuse over adjacent. And lastly, the TOA, right? You can probably guess by now, it's opposite over adjacent for the O and the A. And then, oops, sorry, I wrote that in the wrong spot. That should be tangent. Opposite over adjacent, and cotangent would be the reciprocal of that. So now we have definitions for the trigonometric functions of an acute angle in right triangles, and we're going to see problems that have to deal with triangles, obviously. So let's look at this first one. So a right triangle has legs with lengths 6 centimeters and 3 centimeters. Evaluate the 6 trigonometric functions for the larger acute angle. Okay, well, let's draw our right triangle here. I'm just going to do a little sketch. Right angle. I'm going to label these as A, B, and C. The convention doesn't really matter. I just always write C as being across from the hypotenuse. Okay. Now, when we talk about legs, legs are the non-hypotenuse sides. Okay, so the shorter two sides. Okay. Now, in my diagram, can I really tell which one's 3 centimeters, 3 centimeters, and 6 centimeters? Nah, just make a sketch to the best of your ability. So I'm going to say in my diagram, I think maybe side little b is about 3 centimeters. So, well, I'm going to put that there, and then the 6 centimeters has to go there. Okay, and then I need to find this side yet, right? Because a lot of the sides require the hypotenuse to be known. Okay, so I need to get that. Okay, but then the bigger question is, it says evaluate the 6 trigonometric functions for the larger acute angle. Okay, there are going to be 2 angles. There's going to be angle, let's call that theta 1 and theta 2. Which one do I want to use? I'll give you a moment to take a guess. It is going to be theta 2 as in my diagram, and so I'm just going to erase this. And the reason for that is the shortest side is always across from the smallest angle, and the largest side is always across from the largest angle. So the 90-degree angle is going to be our largest side, but that is not acute, okay? The other 2 remaining angles are going to be acute, but of those 2, angle A, since it is opposite of the 6 centimeter side in my diagram, is going to be the larger of the 2, okay? So I'm going to label my theta as being there in my diagram. All right, so I said we need to find the hypotenuse. Well, how do I do it? Well, you might remember a tool called the Pythagorean theorem. I say Pythagorean theorem. I was just spelling it out. Pythagorean theorem, which says that you can do, in a right triangle, you would do the hypotenuse squared is equal to the opposite side squared plus the adjacent side squared. Okay, and in my context, that's going to be, okay, hypotenuse squared is unknown. Opposite, so that would be the 6. So the opposite with respect to theta, 6 squared plus, and then the adjacent side would be the 3. Okay, so 36 plus 9 is 45. And if I solve for h, I mean, you can leave it as square root of 45. If you simplify it, it would be 3 square root of 5. Okay, so then I can go ahead and find the values of the 6 trigonometric functions. And so here they are. And remember that sine would be opposite over hypotenuse. Okay, so with respect to this angle, theta, this side would be the opposite side. The 3 centimeter side would be the adjacent side. And the 3 root 5, which we found, is going to be the hypotenuse. Okay, so here it would be 6 over 3 square root 5, and I could simplify that further if I wished. Okay, cosecant would be the reciprocal, 3 root 5 over 6. Cosine is adjacent, which is 3 over hypotenuse, which is 3 root 5. Simplify as you wish. Secant will be the reciprocal of cosine. Tangent is going to be opposite, so 6 over 3, which is 2, That's an easy simplification, and cotangent would be the reciprocal of 1/2. Okay, so there we go, folks. Okay, same process for trig functions, just in a triangle. And so here is an example that I want you to pause the video and work on, and resume the video when you're ready to see the solution. And here's the solution. One thing to note is that normally when you do the square root process, you should include the plus or minus. However, we're dealing with acute angles, which means we're always in quadrant 1. So by default, we always use plus when we're working with triangles. Okay, also negative side lengths don't really make sense when we're just talking about a triangle. So there we go.